Oh, haha, I forgot. My audio was muted. Um, I don't know if you can hear me, Alan. Well, at the moment, I am just putting the copper tabs on these bobbins, which is where I'll solder the wires onto, and it's double sided. It's not double sided. It's single sided sticky back copper tape, which I can solder the wires onto. So I'm just getting these ready. I've got my other bobbins apart off the other thing, so I've got to wind these copper coils because one of my bobbins got broken. I thought it would. One of the things broke on it, so I'm going to transplant the wire from this bobbin, which I did in the last few months, and over across to one of these new bobbins, which I've got the holes the right size because these holes are a bit tight. So when I get these, once I've got this done, I've got to put them on the reel-to-reel and wind the coils across, which won't take very long really. And I'll still just test fitting everything as well. I just want to make sure everything's going to go together right before. We're close anyway, we're getting there. I think some of these holes want a little bit more filing actually. It's the outside ones. Some of these holes are still a bit tight. So I'm going to have to file these. That one there is a bit tight, for example. So there's still a bit more filing as well to do. Not a lot. No, it doesn't take that long. On the reel to reel, I stick them on my tape recorder. Doesn't take long at all, really. I mean, I'm not one of these people that spends hours trying to get them all straight and really neat, because there's no point. I mean, as long as the wine is even-ish, that's fine. Now, I've lost where I was. Which one was it? Which one was tight? I think it was that one. Well, that one's a bit tight. I think it's that one. Yeah, it's this one. Wants filing out a bit more. Yes, that one's definitely tight. It won't even go on my file. I want to make sure I've got all these holes filed properly before I start assembling it, because it's not going to be practical to do it when I've got half together. Yeah, this one was definitely really tight. No, it's not solenoid, no. It's using a magnetic switch, which I created. I suppose you haven't seen my diagram. Well, I'll just take this out to show you this. Right, it's something I've been working for the past year. It's a magnetic switch. Basically, every action is reversed, because when when we apply a south pole on one side, we're subtracting the north pole on here, which allows the south pole on the opposite side to be turned on, and the vice versa on the other side. So if this is north on hang on, where's my pen? I'll explain it. Right, I need to get these poles. I need to find out which one's which, because I'm a bit confused. Just a minute. Which is north? That's north, right? Okay. Alright, so that's north this side. North will be on the opposite end there as well. That's south on this side, and south over here. So I'm just doing dots actually, so you want to read it properly. But basically, when we subtract this north down here, this south is actuated on up here, and when we subtract south down here, this north on this side is activated, and yeah. Right, okay, well anyway, the object obviously is to overcome Lenz's law, which is, I've had some good test results with it, so I've basically built this device with many of these in there, and I'll show you my diagram anyway. And I had to get these laminations all cut by laser because they're so fiddly. See the laminations, I don't know if you can see that. Very difficult to see actually. Right. I'll just go and put this back in here a minute. Let me just find a link for it. Computers complain about CPU usage, but that's why it's like that stupid thing that's doing it. Right, here we go, where are we? Well, I'm showing the square design because this is the round one, but the square one's the next one, which I'll be doing. Well, the prototype, which was the early one, was the mechanical one, which I've just dismantled because I want the coils off, because I'm using the same wire. The this is in between. This rotary one is the prototype to the solid state one, and the next one is the diagram which I've just posted up there, which is the square one. And it'll basically let's see, it'll kind of look a bit like this when I get this link up. I can find the damn link. Oh, I think that's the one. So it'll kind of look a bit like this. I hope that link hasn't got broken. It looks a bit weird. No, it should be alright. Well, that's what the square one's going to look like anyway. Our laminations, the next new design. I'm just going to see if I can get you this link as well. It's all my private FTP, so they are online. I don't like putting my stuff online for people can steal it, you know. I actually copy protected it as well, so because that'll stop anyone from patenting it, because it's my work. I don't want anyone else patenting my stuff until I decide what I want the open source community to be able to use it, and these companies patent stuff to keep it out of the hands of us. That's what they do. These big corporations patent something so that we can't use it. Yeah. So I mean, I'll show you what I mean anyway. I'll show you the website if I can find it. Just a minute. Where the hell have I? I can't find this link. The legal. Right. I'll just get this page up. Alright, I'm just going on the website. A minute. That's where I got my patent. I mean my copyright on there. I'm scribing it across now. It's going to be a magnetic amplifier generator, so basically. It's a magnetic switch generator. It's the whole object being to prevent the loading factors. The loading factors from actually impacting the driving circuit, so that we can drive it without actually feeling any what do you call it, reverse action or something. Anyway, I've done a lot of tests with it, and that's why I'm building it, because I'm very confident with it. And there's my diagram, obviously with the one you've just seen. That's on it. I make sure I protect it, because I don't want some corporation. If they was to patent something, that would mean they'd have to break copyright, and which means I'd have them, you see. It's switching. It's a magnetic switch. It switches. It converts a DC. Or let me get this right. It converts a static magnetic field into an alternating magnetic field. Well, most of my videos are showing fragments of stuff, but What do you mean somebody else might have a video, you mean? Oh well, doubt it, because it's all my stuff. I mean, it's the only place I've put it really is on YouTube, and I haven't actually shared my diagrams on YouTube. Oh, maybe I have. I might have done. Oh, right, okay, well that's fine, yeah, because I've got YouTube videos. I do have some YouTube videos, and mostly it's live stream videos, actually, but those are all evidence, aren't they? And anyway, I did the AScribe stuff just as a insurance, because AScribe will keep that information safe indefinitely, because if you look at the terms and conditions on the website, they always keep backups of everything, so it's there to prove the original author and everything. So, well, I mean, I'm copy protecting stuff not because I'm trying to stop other people from making it. In fact, if it works, then I would encourage open source people to build it, but I just don't like the idea of a big corporate body buying all the rights to it and saying, sorry pal, you can't build this, and if you build it we can come around and confiscate it. I just don't like that idea. I mean, that's what Russ is trying to do, isn't it? Russ also wants to find a solution to free energy so that everybody can build it, and that's what I'm basically doing myself. I just don't want somebody to come along and shelve it and say, sorry, you can't make this because it's been copy protected and you're in violation of our patent regulation. I just don't want that happening, you know. I just need to get. There's a video I did with the rotary one on my website. You can go and look at it if you're interested. Let me find a link for you. The one with the rotors I was using on there. You can have a look at that. Just a minute. Hang on. Where are we? I want to go back a little bit. Yeah, but I'm not putting loads of keywords on it. I don't really want my stuff to be easily found actually on YouTube, because it attracts the flies, you know what I mean? It attracts flies, as in the trolls, the people that come around and start attacking you and all that, and you know, this is what happens when you put stuff on YouTube. You get attacked by trolls, and you see, my idea is if this works right, if it works, then the first person I want to share the full build with is somebody like Zero Fossil Fuel, who's already agreed that if it works, he'll replicate it. Now, if he also validates it, then it's safer to go more public, because you don't have the trolls have got no argument then, because then it's been validated. But it's before you prove something can actually work, that's when you get attacked by the trolls. You know what I mean? Right, this. Let me just get this link for you. This is the rotary one I did. It was a test that was done over about 4 or 5 hours, I think. Hang on, what was it? I think it was over 3 hours. Edited it down to about about 8 minutes, I think, or something. So anyway, there's a link. It's speeded up, by the way. It's speeded up, so that was about loading the coil down and checking to see if the actual rotor slowed down or anything. and it's encouraging, but anyway, the solid state one should be much better than that, because I had big problems with the coupling. I had problems with the outside perimeter. I couldn't actuate the outside properly. That's why I'm doing this solid state version, because I will be able to actuate the outside properly. And I'm hoping that the actual power consumption will be less than what I was getting on that rotary one. I was drawing around 100 milliamps, around 110 milliamps, I think, to drive the rotors. Some of these are very tight. I'm going to go through them all. Well, I don't like watching other people's stuff really. I want to come up with my own solutions. I just basically try to work it out and find out what the problem is, how to get around the problem. Yeah, thanks. Yeah, well, I've deliberately kept the calls down to a minimum because I'll explain why. When you start getting the cores, the more iron you have in the center core, the lower the frequency becomes, which means you have to actuate it at lower frequencies. And I am actually aiming to actuate this at higher frequencies, and that's part of the reason for using individual separate cores, because individual separate cores with air gaps and things, it will give me a little bit more flexibility to have higher frequencies than what I would have otherwise if I was using one solid piece of iron. Also, it just works better because you can have more magnets in the game. You can have more magnetic flux in the game. I saw somebody else's design on the internet, and they were using just one magnet, and to me that was just a very inefficient way of doing it, and only one pole as well. But I'm using dual poles, north and south. I think, let me see if I can show you that diagram that I'm referring to. You might actually know of it. Just a minute, let me see if I can find it on here. Just a minute, where is it? Right. Now there was a guy called Tom Bearden. I've included this in a schematic, and I've put my design on the right hand side, which is similar to what I'm doing really, but my switching cores are more efficient. Now Tom Bearden was only using a single pole magnet. Now just a minute, let's get this link up. He was limited because he was using one magnet, but I'm using a different configuration, which is using both poles. So yeah, you're familiar with it, right? Okay. Right, there's a drawing of something which I actually put alongside his. And after thinking about this a lot, I came to the conclusion that my existing design was more efficient than his, and it's along the same principle. But I'm able to use south and the north poles, whereas he was stuck with just one magnet, and he obviously couldn't see a way of improving on that. Well, at least he's not made it public, but I realised when I saw his stuff that I was actually 2 or 3 steps ahead of him, because it was only after I started building my thing that I went and saw that, and I thought, oh, it looks a bit like what I'm doing, but it's not the same, because he's using a solid chunk of iron. Well, not actually, he's using monocrystalline actually. I think he's using monocrystalline, but it's a similar principle anyway. But I've got more effective switching going on, and I'm subtracting a field, and he's trying to push that field. He hasn't got that switching core that I've got. You know, the little V junction. So if he had success, then well, it just gives him more credit, more potential to my build, because I don't know if anyone tried to replicate what he was doing, but and apparently he worked for the military or something. So yeah, no, okay, Alan, no worries. Alright, you take care, Alan. Right, let me just make sure I've got all these. Yeah, I keep getting friend requests on Facebook from military people, and I always avoid them because I don't know who they are. I think they're trolls or some impersonating. Yeah, well, I wonder where he is now. That's the question. I just don't like attracting attention. I prefer a quiet life, you know. Ah, this one's tight as well. It's really just the outside ones I need to redo a bit because they're a bit tight. Yeah, it's better to have your own designs, and you can't get no flack from anyone. Yeah. Sorry about the squeak. Yeah, there's too many trolls, there really is, and I'll tell you, once you get a troll on your site, once you get somebody that's decided to have it in for you, then they bring all their pals along, you know, they just pass word along, and you end up with about half a dozen of them all giving you a hard time. Yeah, herpes is a disease, yeah. I've had my experience of trolls in the past, but not personally. when I was a moderator on a website, there was a few of us moderating, and we had a whole bunch of trolls on there, and it just got very, very messy, and I was just glad it wasn't my site. But you got to be careful what you say. You say the wrong thing, and the next thing you know, you're getting attacked for it, you know. So I'm just sticking by the simple phrase that this is a magnetic switch. I'm not making any claims about it or anything like that. It's a magnetic switch, that's it, period. Yeah, they are actually. You're right about that. There are certain powers that be that pay them to go and harass people. Yeah. To either get your site taken down or get you taken out or something. That's why I like going on live stream. It's disconnected from YouTube, so I can choose what I upload onto YouTube. Because YouTube's just got too many of them, and right, I think that bobbin's just about there, ready. I'm hoping Russ will come on soon, but let's see, is there any tight ones on this one? I can see just by looking through the holes which ones are tight. I think that one's good too, so those two are both good. I've done the inside ones already. Actually, I could just put my file through just to make sure. Z! Oh my god, Z! I hope he's got good news for us. So I'm just going through just to make sure I've got all these holes, so I haven't missed any. I don't want to get this halfway assembled and find out that I've missed one. That one's a bit tight, actually. I'm using diamond drills, diamond files, and they're very, very good. Yeah, this hole was a little bit tight, and I'm just running my file through it a bit more. Well, the inside ones don't squeak. It's just the outside rim that does. I need to check the inside ones on this as well, because I didn't check the inside ones on this one, so that's just, actually there's a bit tight in there. So I'm going to be winding the coils tonight. Oh, cool! I'm going to be watching Z then. Ha! Well, okay, if Z's going to be on, don't expect me to be doing anything, because I'm going to be watching him. um, oh. Yeah, I definitely want to be. Well, I'm going to be winding my coils. I was going to do it tonight, but if Z's going to be on, then I'll probably do them tomorrow. I don't know yet. I'll see. But this job is nearly there, because once I've got the coils on, the assembly of the laminations is not going to take long, really. It's not going to. Well, in saying that, there might be some little adjustments with gaps and spacing and padding and things like that to do, but at least we'll be nearly there. And then there's just a circuit to build, and that I'm going to do that on the breadboard. JB blabbing about. Who's JB? There's somebody else live as well. I don't see anybody else that's on. Oh, JB. Yeah, this one was a bit tight. That's better. See all that dust? That's how much this file takes off. It's really good. Right, was this one I need to check as well? Yeah, I think this one's got some tight ones. Yeah, definitely. Nearly there. It's just the outside ones I haven't finished off. Well, technically I'm a she. Everybody gets me mixed up because of my gender issues and maybe I should come back as a mouse. mice always get called mice, and that's it. Period. Oh, a hamster. No, you didn't. No, you're all right. Everyone does it. Everyone does it. It's just my voice. Well, except actually, I don't get that when I go into stores locally to me. Everyone treats me well. Everyone talks to me because I've got my handbag on my shoulder, so they don't question it. You know. Z thinks you're talking to him. He hasn't. I've told him I'm live. He doesn't realise you're talking to me. I think you are anyway. Oh, I don't know if he's talking to me or not. I don't know. I'm confused now. I should be typing in the chat. Alright, this one's a bit tight too. Yeah, well, just tell him you're talking to me in on the stream. Then he'll know it, because he thinks you're talking about him. I just can't type and file at the same time. You know, it's not practical. Oh, now I've got to roll now. It's a compulsion. You see somebody typing a roll and you've got to do one. What's with these threes? We're getting threes again. I don't believe this. Last week there's 3 of us got 3 or something. It's just crazy. Oh no, we're doing it again. 3 of us have got 3. Oh no, oh no, you've done it twice and you've got 2 3s. I don't know what it is with this dice. I just don't know. I just realised something. I don't think my live stream works for Z on his Linux. Maybe, I don't know. I'll roll 100 or something. I don't know. Hang on. I'll try another 6. Yeah, I'm getting smaller. Well, try the big one. Oh, that's more like, hey, that's how old I am right now. Damn it, that's my age. I'll be 58 in 10 days. Well, well, as you get older, the weeks and the days start ticking by faster and faster, and this dust is getting me. Well, we'll be watching the oh no, this is tight as well. Me enjoying this. Ugh. I'll be glad when I've finished it. Yeah, now he hangs around. Right. Well, I give up, you know. I just gave up typing goodnight to him because honestly, he just never hangs around. And the one night he does hang around, I'm busy filing. That is just typical of him. Typical of Z. He normally says good night and he's gone and that's it. And he doesn't even get to see you reply. Right, this bobbin is done, I think. It's just ready for the coils winding on there, and I'm just checking the inside. Just any tight spots I just want to get out. I don't want to break. This one's a bit tight. Oh right, the cache yeah, the cache thing. I did hear about some of that, but I think it was a bit before my time actually. It was before I came on here, before I met Russ. I had to go back and watch a lot of stuff because there was stuff that Z had done that I never knew about. And I was busy a few years ago. I was into all the spiritual stuff, and I was kind of preoccupied with all that, and that was a distraction from getting on with my life really, just building something instead of just meditating and bollocks. Anyway, a lot of people I know are still in that and are not accomplishing anything useful. It's apathy, you see. You get trapped in this apathetic world. It's part of the globalist plan to make everybody lazy and meditate and do nothing and think they can wish all the problems away, and that just does not work. you can't wish the world into a better place. You've got to physically make changes to make the world a better place. But sadly, a lot of people just don't get it. And you can meditate under a tree until the cows come home to try to make the skies pure and and the food safe to eat, but it's not going to actually do any good unless you start complaining. Yeah, that's right. It's all throughout our history. Action is what people have got to do. You've got to make your voice heard, and the globalists are trying to silence us, and that's what all this freedom, this censorship's going on right now, to block people's free speech. While everybody's meditating under trees, they're stripping them of the rights to actually say and speak out against the wrongdoings. And when they do decide to come out from under that tree and say, I think I've been asleep, I need to complain. Sorry pal, it's too late, you can't do that now, you'll get thrown in jail. But if you open your mouth and say the wrong thing, that's it, you're in chains. Oh dear, I should have done something sooner. Yes, you should have done something sooner, but you were asleep. You know, that's the kind of situation. Yeah. We are creators, and you can't create if you're sitting under a tree, can you? God, do you see all that dust? Yeah, that's it. It's hypnotism. That's right. And it's not a new thing. The spiritual movement is a good thing in some respects. Don't get me wrong, but there's a time for prayer, or a time for meditation, and there's a time for action, and you can't combine all of those into one. And now, technically speaking, all of these should fit easily now. I've got all these other laminations to put in, obviously, once I get the bobbins round. There's actually 3, you know, by the way. Don't misbe. There's an interlace going on. When this is built, there'll actually be 2 magnet actuations on each side, and then it'll be about this. It'll be about that long. So I've got to. I've got another. Hang on, let me just get the other piece as well. I'm not sure if I finished this. This other one, I've been filing the slots out on this other one. I think I've still got. Oh yeah, I think I've still got some filing on this one to do yet. Yeah, I just remembered I have still got some filing on this one to do because the magnets are tight on some of these, and now I've just got a bit ahead of myself. So that one's okay. That one's okay. There's some of these I just need. That one's tight. That needs filing. So that's not ready yet. Yeah, I've still got some filing to do on this this other one here, because when I get this, when I'm ready, it'll be kind of like this, right? Oops, it'll be like that really. Generator coil in the middle, actuation coils on each end, with all the laminations running staggered. So the laminations will be through this side like this, with the ends on, and it'll also be through here up to this bobbin, right? So it'll be interlaced. So the centre bobbin will be completely surrounded by laminations, but the ones on the end will only have half that the lamination. So there's actually 12 slots altogether. So there'll be 6 laminations on this going around this here, 6 on this going around here, and there'll be 12 overlapping on here. If you get the idea. But I have still got some filing on this other one to do, and I forgot that wasn't done yet. So yeah, well, I'm going to be watching Z tonight. No, it's not the rotor version. No, this is the solid state version. It's a solid state version without. That's why I've got these laminations with the little ends on like this, because it turns the magnetic field back, and it turns it around, so you've got a complete circuit. Take the bobbin off a minute, you can see what I mean. Just a minute. You can see that they stick with the magnets, because the magnets they form a complete circuit, magnetic circuit. Get this on there. Oh, I've got these staggered a bit. Hang on. Just a minute. Right, you can see the coils will actually be on the bobbins, will actually be surrounded by the laminations, so the coils will actually be between the laminations. Damn it, I'm having trouble holding this on here at the moment because the bobbin's not on there. Right, so the bobbin will be all the way around, obviously, and the coils will be running between these laminations. So we're going to have a much better gain of, we're going to have a huge gain in magnetic flux between the coil, around the coils, so we'll see a much better performance than what I did previously, because both the outside lamination and the inside lamination will be switched, whereas the rotary one with the rotary discs, I wasn't able to actuate the outside properly because of the way the flux was travelling. I wasn't able to guide it very well, but it'll be a lot easier with this other design. So just imagine these going all the way around, because that's where it's going to be, and it'll be a complete cage effect. It looks a bit like a bird cage when it's together, actually. Yeah, I can't wait either. I'm eager to see it. But all my laminations for this are all on this. Let's get it over and I'll show you what I mean. Oh, my magnets are stuck to my back. Oh, damn it. Oh. Look at all my magnets, right? There's all my magnets on this plate. A lot of magnets neodymium M52s. And my plates with all my laminations in are over here, look. All the laminations ready to be taken out of the panel. So they've got to be pulled out, and that's one sheet. On the other sheet, I've got the other laminations underneath. So I'll just take them out when I'm ready. I keep catching them with my finger, and when you do that, they get bent. So, so those are all the laminations. These two sheets together, I'd cut them in half, but when they were stood up on the floor, they were 4 foot tall, and that's a lot of laminations in here. Yeah. Yeah, where you push them out. Yeah, it's similar actually. It's a very similar principle. Yeah, as I say, all the N52s, and my magnetic gauge. Right, we'll just test them. It's a gauge. I made this magnetic gauge for testing magnetic flux, and you can see that they're all alternated. Oh. And I've got another one which is for south. I made it out of ball bearings and magnets. That's all that is. Oh my god, are you walking around talking to me? Well, be careful, don't hurt yourself. So these are the N52s, these are the 20mm ones. Did I make you trip over or rolling on the floor laughing or something? Yeah, what happened? You said there was an accident. What happened? Oh my god. I hope there's no one, damn it. Oh wow. I hope nothing's serious. I hope they're alright. Oh, that's a relief. Good. I'm glad they're alright. That's good. Yeah, I'll stick this other bobbin on here for now. Well, it looks like the filing's done. I think everything fits really well with that. I think I'm going to wait for Z to come on, because he should be on. He said he was. Didn't he say he was coming on tonight? I thought he said he was going. He was going to be doing some work tonight. So that. Just looking at the clock and thinking, hang on, that must be quite late. I mean, it must be 10:30 where he is. Oh no, this one's tight still. What's the matter with this? Oh, I've got it the wrong way around, that's why. I got my laminations wrong way around. Oh, which... Have I? Yeah, I did. That's it. Right, so I'm probably not going to get the coils wound tonight, because if Z's coming on, I want to watch that. But I need to finish filing this thing as well. So I forgot about this. I was halfway through it, and now I haven't finished it. So this other magnet holder needs some more filing doing. So it looks like it's going to be tomorrow now. But at least we're getting there. I'll put these somewhere safe, and I won't knock anything off. Oh, there was something else I was going to do, which I can still do. I can drill them holes. I have some holes to drill. Nearly forgot about that. Right. It's just where the connections go for the wires. I need to drill some holes. Won't take me long. My drill's running at a slow speed. Oh. I need to speed things up a bit. It's copper foil. It's sticky copper foil that I put on there. It's tape. This is a copper tape that I put on there to make the solder connections. This stuff. Oh, it's resin. It's fiberglass resin. I cast them in my molds. The original patterns. This is a 3D printed bobbin, I use it to make my mould. Where the heck's my mould gone? I can't see it now. Just a minute, where is it? Right, here's one of my moulds. It's silicone rubber. And I make copies of the bobbin. I put some nail varnish on there just to hold the little inside parts where the actual laminations go. It's held together with some. But this is my silicone mould, and I make them out of resin, so I can make more of them when I want. You see. So basically, I can make replicas of all my parts. I mean, if you haven't been following me for the last few months or whatever, but I have got moles coming out my ears. It's another mould. That's for the magnet holder. This mould is for this mould is to make more of these. Right. So it's flexible. When I want another one of these, I just mould it in there, but there's a bit of shrinkage, you see, which is a problem. The resin actually shrinks a bit in the oven, so that's the reason I have to file them out a little bit. And here's some earlier prototypes. These are the earlier ones I made, and that was the concentric 6 I made, magnet holder. So I've got a few different molds on here. Getting a bit dusty now. And that was for a C12 magnet holder. And there's one there with some resin in it, which I haven't pulled out yet. There's actually some resin in there. That was an earlier one which I haven't bothered. I'm not bothered with these now, so you can see the resin's in there. Look, I could pull it out if I wanted to, but I've kind of left it in. You can see the resin. It splits. It comes in half like this. Look, and you can see that the actual resin bobbin is still inside. I don't know if that's a bit bright actually, you might not be able to see it properly. But there's a bobbin in there right now. This lamp's in the way, innit? Better if we just hold it on the table, I think. So there's a bobbin that's in there, which I've never bothered to take out because I don't need those right now. Hi Nick. Yeah, I've been doing this for about a year now. Right, I've got to drill these others. I'm not going to take this one apart to drill it. I think I can do it without taking it all out of there. it's just where the wires go through, and when I wind them, it'll stop them coming on off the bobbin as well. Yeah, well, the early designs were all based on the rotary system, and I had a huge problem getting enough flux to switch, and but this one will be a lot better. I know it will. I've spent a lot of time thinking about it. I've had about 4 months to think about this new design. That's why I designed the square one, which is the next one to be built, and obviously I'll be getting all the parts made for that once I'm happy with the results from this one. And if there's any modifications that I need to make to the square one, it won't be too late to do that either. Anyway, I'm just gonna pack up now and go and check Z out, because where is he? He should be live by now. I'm going to do the bobbins tomorrow, I think. I'll wind them, I mean. I'll do that. There's no rush. And I've got some more filing on that other bobbin to do as well. I mean, that other magnet holder to do, so there's still a bit to do yet. Hi, welcome, Jay. Yeah, I'll show you these anyway. Hang on. These are some earlier bobbins I made with, and they've actually got iron cores in them. These were the C6s. These are the C6s. And they've got iron cores through them. There's 3 in each one, and there's 6 cores altogether. And these cores are still inside. And yeah, this was something I built and we tested out, but it was all this was rotary stuff. What gauge? What wire you mean, or laminations? It's about 1mm thick, about. It's 30 SWG wire for the actual, well, it was 30 SWG wire that actually I've got some other bobbins up here, hang on. These are some of the bobbins that I made for the rotary one, and this was also 30 SWG, and this was using a single corridor. This was an earlier prototype. This is before I did the magnetic switch, right? And these have single cores. These do not have the magnetic switch, right? But they had a C6 core. Hang on, where is it? Well, they did have a magnetic switch, but it was a single. It was, just a minute. Right, these are the C6s. These were the first ones I started working on, right? And there's neodymiums, and I made these out of magnetite and resin. These have very hard because they've got magnetite mixed in with the resin. And to show you how it worked, if I get my magnetic gauge, right, and put this in the center, you'll notice that there's nothing happening right now. Right, but there are magnets all the way around, but the magnets are in such a way that they cancel each other out. Now, they cancel each other out at the moment until you apply an external magnetic force on this side, which subtracts the dissimilar field. So if I put north, or what is this anyway? This is north and there. So if I put a south-facing magnet on this side, then the south-facing magnets around the concentric will be deflected towards this gauge. So if I get this the right way around, you can see it switches it on. Right, it's on now, look. Right. Now if I remove this, it doesn't take much effort to remove this, because this magnet that I'm holding in my hand is both pushing and pulling at the same time. So the only force I have to deal with is the actual traction to that piece of iron in the middle. And as I move this back, that switch is turned off, right? So the amount of force I'm using to turn that on is very small. Like that. Now if I get the other opposite side of now, I'll put this there. Now if I get a pair of pliers, let's see, get a steel washer, right, for example, put this steel washer on here, right. Now the magnets are cancel each other out. Now if I put this piece of scissors on there, nothing, look. Right, nothing. It's not lifting it. I'll put it on the table so you can see. But when I touch this steel in the middle, it's not picking it up, is it? Right? Now if I bias it with this magnet on the other side, if I can get this in, I need something to hold it straight. Just a minute. I use this plastic. I use this other plastic C12, but there's actually no magnets in there. So I'll put this in the middle. I'm trying to get this magnet to stay in the middle. It's a bit tricky. Bloody thing. It's because I'm on a round thing. Now this should be on now. Actually, I use my pliers, just a minute. Look at that, it's on. It's actually stuck to this now, look, because it's biased underneath. Now if we move the magnets on the other side, which will come off easily, now watch the amount of force that I don't need to stick to the outside of the magnets, but now the amount of force required to remove the magnets on this side is very little compared to the force that's engaged on this side. Now if I hold this at a distance, if I can hold this at a distance, you should see that these pliers will stay attached. Oops, damn it. The pliers should stay attached until I've got a fair distance between these magnets underneath. If I can do this right, I think I'm doing the experiment upside down, to be honest. Just a minute. Put the pliers on there. I need these pliers are too big Where's my nail clipper things? I get the nail clippers. These seem to be better. Right. I've got the nail clippers now on there, right? They're stuck to the outside of there though, that's the problem. Now if I stick that like that's proper, right? It's not sticking on there right now, look. Now put this on, now it's holding them, look. And I remove it, oh it's gone to the outside of the magnet now. It's not sticking to the middle. Now it's on, but when it turns off, these tend to jump to the side to where the magnets are. Now it should drop off. There we go. Right. So I did some actual tests on YouTube. You can go and check it out actually, if I can find the link. But I did some measurements with weight and the amount of weight that this was actually able to lift up compared to the amount of force that I was using to actually actuate it, and the amount of force I was using to actuate this was a lot less than the amount of force that it was able to lift on the other side, right? I did some weights and things, so that's holding that. I'm going to take this away, it's gone. Right, let's see how far back I can get. I'm about an inch, 2 inches, 3 inches, was it 2 inches? There, it drops there. As I say, I can switch the polarity on that either way. So one way is north, so that's north. Get my other gauge, this one, which is south. I'll swap it over for the south one, and that's south, but it's not sensitive, so the south one isn't. It's a shorter tube, but you can see it's turning south on there. I use a bit of gravity as well to help it, but you can see the north one is a bit longer. If you look, it makes a difference, and the magnets are actually further, they're closer together on the south, so I've got more opposition there. I'll find you that video where I did some tests. You'll find that really interesting, because these cores actually went with this, you see, and it wasn't very efficient, because lack of there was no laminations going around, you see. That was the problem, and so there's no reason why I couldn't experiment with actuating this with another coil. I could do, and I might even do that at some point. By having an actuation coil on this side to switch the core magnetic flux onto this core on the other side, I could do that, because I've still got these C6s. I've got plenty of these lying around. I've got 2 of them actually here. I've got 2 of them here. I'll take the washer off. I don't really need that at the moment. But I'll go and show you that other video that I did. You might want to check it out. Yeah, well, I could use a very small coil actually. To actuate this, it doesn't require much power at all. Very, very little power to turn this on and off. But we get quite a huge gain coming out the other side. So yeah, technically I could put a small coil, a very small coil, on here, something like one of these. These are stuck on with a bit of these are just stuck on with a bit of blue tack. Now if I take that coil off there, it's full of blue tack at the moment. Yeah, footer gate, yeah. Yeah, I could do that at some point. I'll just get you this blue tack off here. And I've got some, actually I've got some magnetic, that rubberized magnetic stuff that's in the middle of here. I was using it as a core. I don't want to break these bobbins, these tiny ones, because there we go, I've got this out. Yeah, these came out of these actually came out of one of them those little ferrite transformers. Yeah, and well, I could stick that on there like that and actuate it. Yeah, could do something like that just to try it out. But as I say, I want to get this other build done first, because I think that this new build is going to be much better than I haven't actually tried putting power through here. Let's just see what happens. It might be too much power, too much current though, because my lamp runs on 12 volts. Now if I short these wires across this lamp, it's actually running off my solar battery. I wonder what's going to happen. Oh, it shorts my lamp out. Yeah, my lamp just doesn't have the power to drive this little coil. It would have to be done at high frequency, you know. Higher the frequency for an air core like this, probably talking about 200, 300 kilohertz or something like that. You know, very high frequency or something like that, or maybe higher than that, but I would say probably, as a guess, based on this copper the wire thickness, I think we'd be talking 512 kilohertz for something like this. And if it's got an iron core as well, it would be a bit lower. I haven't tested the actual millihenries of this with no core in it, but I could do. But anyway, I want to get this other build done. I'll stick this back on here for now so I don't lose it. Oh, it won't stick now. What do you know? Huh. I know why. It's because this was in I think I superglued this together. This is that magnetic rubber stuff, you know. I'll go and find you that video, because I think you'll find it very interesting. Heights, and all the others have seen it. Something I was doing last year. I'll stick that in there for now. I'm going to move these out of the way. I have to be careful to put magnets near my tapes. It's so easy to forget. Right, let me just find you this video that I did. Right. I'll just put the live stream on so you can see what I'm looking at. Um, right, going back. Um, I'm just trying to think how many months back it was now. There it is, weights and measures. I think that's the one. Hang on. Pretty sure that's the one I did. I think it is. Maybe not. I don't know. Let me just double check.
Right. There's another batch of washers I'm putting. Well, I've got.
Let me go, folks. It might not be this one.
I'm looking for the other one with the blue on it. Where's the other?
Hang on. Where are we?
And this is my middle concentric at the moment. And this is the one that goes to the centre.
Right, let's see.
Coil, and I've actually got two C6s in the middle, which doesn't work. I've tried it out just to see, but it does not work. You only need one concentric in the middle, actually. Instead of it going past the wires, which went through the middle, and the magnet, and this will pulse the steel washer, which is here. I'll have a slot.
That's not the right one. I need to find the one that I did. So just a minute. Where is it? Some of my videos are not public, you see, so I might have to give you a link directly to it. I'll just check the chat, hang on. Yeah, I don't want to give away too much on my YouTube because I don't want somebody else even beating me to the punch, you know what I mean? And obviously if later I've proven it and I've got it copy protected, then I can make it public, you see, as a reference, because it'll have the date stamp on it when I uploaded it and all that. So right, where the heck is it? think I've gone too far back actually, but let's have a look. It might be this one.
Right, well, I'm starting to, I'm getting all my parts. I'm starting to make the...
No, it's not this one. Hang on a minute. Alright, cool. Yeah, I'm still. When I find the video, I'll give you the link. Yeah, it's further. It's actually earlier than this, so. I've gone too far back now. I've gone back to November 2016. That's too early. Well, it's got to be here somewhere.
Basically, at the moment, I've got a bit of a nightmare. I put too much steel on the outside. I need more iron on the inside and less on the outside because that was causing me a lot of problems with breaking. So I'm using acetone to melt the super glue. It's taking me a while. This stuff is pretty strong. But I'm trying to, yeah, I'm not having much luck at the moment. I'm using a screwdriver and I'm trying to wedge these little bars off that I glued on.
Not this one.
This should come loose in a bit. God, what a nightmare. I've got to be careful because I don't want to break my bodies inside because they're also susceptible to acetone. I've got these felt.
No, it's not this one. You can't use super glue after the incident. Oh, I don't know what that is. I used to be in electronics. I used to work in a hi-fi shop years ago, back in the 90s. I used to fix CD players, calibrate lasers. But before that, I've been. It's a hobby stuff. I was making stuff. I made my first disco light switching using a loudspeaker diaphragm to operate micro switches to make lights flash. That was something I did when I was still at school, when I was like 12 or 13 or 14, you know. I've been doing stuff all my life really. And it was back in the 90s. I was working on a lot of high quality hi-fi equipment like Bose and JVC, valve amps and all sorts of stuff. Yeah, it's a passion, yeah. I even got into CB radio repairs. I got into CB radio. I found out there's a bunch of people complaining because they'd blown their output transistors, saying, "Oh, I'm on a walkie-talkie now because my rig's not working." And I sort of put the word around. I says, "Well, I fix CBs, electronics and stuff." So everybody started coming around to see me, and I was making a little bit of pocket money, you know, on the side, you know, fixing CB radios as well. And yeah, it was, yeah, I was making transmitters and all sorts. Let me just see. It might be this one.
Right, well, the next stage was basically I had this ferrite ring on here, and I filled resin around I had silicon, obviously. The silicon will come off now, and then I poured resin around the outside, and poured some resin around the small gap in the centre. Hang on.
No, it's not this one. No, it's not this one. Hang on. Modding rings. Yeah, I made some antennas as well. Kind of left them all behind because CB's gone dead around here. We don't really. There's no demand for CB radio around where I live anymore. You're lucky to find anybody on at all. I've still got a CB next to me actually, but my antenna. I took my antenna down because the flipping fire brigade were complaining. I got wires everywhere saying it was a danger to firemen if there was a fire, and they got tangled in wires. And I thought, oh, a lot of shit, you know. But I can't really put an antenna up outside because it's not my building. I don't own it, so you know. Okay, let's find. Let me just see. I did this V-coupling thing. You might find that interesting. I'll just play a bit of that. That was what brought me to the magnetic switch, the improved design with the laminations.
Okay, right, here we go. You can't really see this, but now that I've got, but basically I've got steel wires inside the core that goes inside the concentric. Now the wires are actually in a V formation. I'm actually looking at it upside down, so it's more like, hang on. Right. But if I rotate it, you can see that I've got the steel wires that kind of, this basically acts like a magnetic switch, right? The magnetic field, concentric, is sent to the edge through these wires here. And we have rotor magnets that pulse the magnetic field along the wires that meet at the junction. And that determines the magnetic flux, the direction, whether or not it flows to the ball on the other side, or whether or not it's diverted back to the rotors. Now, because there's one magnet's pushing here, so that's south, the next one might be north, and the next one might be south, and north, and south, so on. And because it's equalised, the rotors don't actually feel any extra work because they're actually pulling and pushing at the same time. So the amount of work being done is negligible, but we're actually switching the magnetic field from the concentric magnet because the magnetic field is being pulled in that direction, and the other magnetic field is being pushed to the ball. So we either south or north on the ball on the other side. Now to demonstrate this, I have another one in the core right now, and at the moment, see, if I put my magnetic gauge near the ball, actually the rotor field. Let's just make sure I get this right amount. Just hang on. Oh, damn it. Sorry about that. I'm trying to get this off here. I'm trying. Magnets bite you sometimes.
I'll just pause that a minute. I'll give you a link to it. You can go and watch that while I'm looking for the other one. But that's a link to that video. Go and watch the video. It's interesting. You might find it's based on my magnetic switch. And it's a bit dark, so and I've got a fog in my throat, and I'm going to keep looking for the one I did with the weights. And yeah, I love playing with magnets. You know, I always have done. I think my fascination with magnets started when I was about 5 years old, when I had a train set, and I was kind of puzzled why paper clips and things used to stick to the train. I was little, and it just, you know, I kind of thought, why do things keep sticking to my train? You know, I was little and I didn't understand, and then I got my hands on a screwdriver and all hell broke loose because I started taking my train apart. And yeah, well, I think Russ has a similar story. I think he's done something similar to that. But it's the magic of magnets that pulls you in. Anyway, you go and check that video out, and I'll just see if I can find this one where I did with the scales. This might be the one.
Okay, we're going to
Yeah.
do this other test.
Yeah, this is the one. I found it. Right, I'm going to give you the link for this one as well. I need to put some comments in there. I need to re-edit that. I'll just call it weights. Okay. I actually did that in December as well. Z's still not on. I don't know why. I might watch this myself again actually, because it's been a while since I checked it, and oh my god, it's only got like, well, it's got 42 views, which is not bad.
Let's see.
I'm going to mute my sound. I'm going to mute my sound for a bit while I watch this video and you watch it as well, because I'm not sure. I might have to kill the stream actually. Let's have a look. Well, actually, I think I'll kill the stream because I'm at 2 hours and 21 minutes, and I don't want this video to get auto saved. It won't. It'll only get stuck anyway because. So I'm going to wait and see if Z comes on. I'm just going to stop the video stream, and we'll carry on and chat